Hi guys, welcome back to AvidForte, and today we're going to discuss a few questions sent to us by our subscribers, our students and our viewers on the topic of acoustics. So in acoustics you have many topics like reverberation time, Sabine equation, Haas effect, and how sound behaves, what loudness is, what pressure levels are, power levels are, intensities are. But okay, we'll try to take all these questions, but we will not get into the depths of theory. We will just be discussing the numericals and how to solve them and how I can give you confidence in this subject. But again, there are many disclaimers that this is not the exhaustive list. You can always expect questions beyond these, and yes, these turn out to be coincidentally gate questions also. So the first question which they have asked is, the internal dimension of a room is 10 by 10 by 4 meters. So as soon as you see the first line, you know you have a volume. If you have a volume of a room and somewhere the reverberation time comes across your vision, so you know, okay, we have the volume for the formula. And then keeping the doors and the windows closed, the doors and the windows have an area of 16 square meters, fine. And they are in the closed condition, the reverberation time turns out to be 1.2 seconds. And assume the internal surfaces including doors and windows have some absorption coefficient. So you are supposed to assume any absorption coefficient. If you are deep into the theory, you would know, okay, they might be different, there might be different formulae, there will be different processes involved. But for here, just take an alpha. That is what they have said. They have made it easy for you. Next, if all the doors and windows are kept open. Now, if a door and a window is kept open, let's say I clench my fist, sound gets absorbed, but if I keep my the gaps between my fingers open, sound will pass through, just like in case of doors and windows. So there won't be any absorption there, zero absorption, sound passes by. So if they are open, the absorption as a whole is gonna go down, and then the numerator is gonna be constant because it's 0.161 into times volume. So the reverberation time is gonna go up ideally. So let's say you had 4 options and they had 0.3, 0.6, 1.2 and 1.3, you would go for 1.3 because straight away it's more than 1.2, everything else is less than 1.2. So that's a small trick. You can always use your IQ in the examination, otherwise we'll try and solve it. So I have the volume of 400 cubic meters and then a total surface area. I have a 10 by 10 grid, so 10 into 4 is 40, 4, 160 square meters of wall surface area. And then I have the floor surface area of 100 and ceiling of 100, 200 and 160, 360 square meters of surface area I have. See, I did it mentally, you can also do it mentally. Need not use any calculator, any formula. So 360 square meters of surface area, and you have 400 cubic meters of volume. So you easily get the formula that reverberation time equals 0.161 V by A, capital A, where A is the absorption. So you have A equals S alpha. You do not know the alpha, but you know the S, or the surface area. So you would anyways get an alpha of, let's say, whatever the alpha turns out to be. I'll share the answer with you in the solution that I put up. So alpha turns out to be something. Let's say, okay, we find the alpha to be 1.47 or 1.48. Let's say I don't know. Just keep it like a fraction and move on to the next stage. In the next stage, 16 square meters of area is being removed from the absorption area. So the total surface area which contributes to absorption becomes 16 square meters less attributed to door and window areas than the total surface area of 360. So it's 344 square meters. So the reverberation time will be different. So the reverberation time is unknown, which equals 0.16 times volume, which is the constant, same volume did not change, divided by capital the surface area, which is 344, into alpha, which you just calculated. If you have the fraction, if you have the decimal number, fine, you otherwise just substitute the fractional numbers, they resolve themselves. And last time I checked, this answer was supposed to be somewhere between 1.25 and 1.28, whatever the answer was, I'm going to put it up. But see, I did everything mentally right in front of you. This is because I had a 24 rank, I'm good in maths, I'm good with numbers. You should also try and uplift your capacity, the level of calculations that you can do mentally, so that in the exam you don't waste even 5 seconds on the calculator. I mean, try to calculate the answer. So let's move on to the next question. This question is super easy. If you want me to solve, I can do it in 2 seconds, but I'll explain. So I'll take up a minute. So they have given you four units: decibels, fons, sabines, and watt per meter squared. These are the 4 units you have to read about anyways. But you should know what units what they represent. Just like watt per meter square always represents intensity, I0, 10 to the power minus 12 watt per meter square, always a constant. So straight away you know, okay, this is intensity. Fons, equal loudness curves, remember. At 1000 hertz frequency, 1 fon equals 1 decibel. Yes, only at 1000 hertz frequency. If I change the frequency, there's no guarantee it's going to be the same, because you have to look up the equal loudness curve and know the concept behind it. So you would know. Decibels, did I discuss decibels? No, I don't think so. So decibels is how your ears perceive a sound. Your ears do not perceive a sound in terms of 10 to the power minus 6 watt per meter squared. They'd rather perceive it as 60 decibels. In fact, ears don't have an instrument. You express sound in terms of decibels to represent how your ears are reacting to that sound. So decibels obviously would represent the sound pressure levels, because when air is compressed and the sound wave travels, it changes it puts pressure on your eardrums, and that creates the sensation of sound inside your the auditory nerves, and that's how you perceive sound. Finally, fons is for loudness. I mean, don't even ask it. I just explained. It is so easy. So I'll move on to the next question. So in this question they are saying there's a wall. Let's say assume this is a wall, and there are 2 sides of this wall. On one side you have a high intensity, now which is a higher number, 10 to the power minus 4 or 10 to the power minus 7. Revise your maths once if you are still unsure about it. 10 to the power minus 4 is a higher number. 10 to the power minus 1 is 1/10. 10 to the power minus 2 is 1/100th. So 1/10 is larger than 1/100th, which is very small. 1/1,000,000th is even smaller. So the larger the negative power, the smaller the number is. Just the reverse of positive powers. So 10 to the power minus 4 on the higher side, 10 to the power minus 7 on the lower side. So what is that intensity drop in terms of decibels? That's all. So you know, if you have to convert intensity to decibels, use the formula decibel equals 10 log I by I0. I0 is always a universal constant of 10 to the power minus 12 watt per meter squared. So you have 10 to the power minus 7 and 10 to the power minus 12, which is 10 to the power 5 difference if you do the ratio. So that 10 log base 10 of 10 to the power 5 will give you 5 on the outside, and log base 10 of 10 will be 1. So 5 multiplied by the initial 10, because 10 log I by I0. So that will give you 50 decibels. And 10 to the power minus 4 would equally have given you 80 decibels. Yes, 4, 12, gap of 8. So 80 decibels. So what is the decibel drop across the wall? 30 decibels. 80 minus 50, and that's all. That is what the question is. You literally did not have to solve, even just mental maths, you could have got the answer. These are the kinds of questions you are asking me to solve. I mean, come up with something more difficult, please. Now this question I will take up a lot of time to explain, because it's the last chance you have to understand the concepts of Sabine's equation and reverberation time. They have said, they have given a room, they have given a tabular format of materials and absorption coefficients for those also. They have given a room of dimension 4 into 3 into 3, that is 3 3s are 9 for 36 cubic meters. And then they have also mentioned that for the wall, the wall has been supplied with different absorbing materials, 70% of which has an absorption coefficient of 0.1 and 30% of the wall having an absorption coefficient of 0.4. Similarly, the ceiling has been supplied with different sound absorbing materials, so they have segregated the percentages 60, 40 and I think 0.6, 0.1, and they have said there is a uniform absorbing material on the floor, so there is no change, and the absorption coefficient is of 0.1. Now, given the conditions, you can easily find out this total surface area of the walls, because 4 into 3 is 12 into 2 24 and 3 into 3 is 9 into 2 is 18, so 34 and 8 42 square meters of surface area of the wall, and 4 into 3 is 12 for the floor and 4 into 3 is 12 for the ceiling. After you calculate the volume and the total surface area for all the surfaces of the room, you have to segregate the walls first, because they have said 70% of the walls have an absorption coefficient of 0.1. So S1 alpha 1 plus S2 alpha 2 for the total surface area for the walls. Now for the ceiling, surface area of ceiling divided into two parts. Again, SC1 alpha C1 plus SC2 alpha C2 gives you the total absorption for the ceiling itself. Similarly, for the floor, there is only one material, one absorption coefficient. So S alpha for the floor, let's say S subscript F alpha subscript F for the floor, whatever the values are, I am going to put those up, but this is a very simple concept. Now you add up all the S alphas, so you get the total absorption. This total absorption is going to go where? In the reverberation time calculations. You are going to get the reverberation time by putting in 0.161 total volume of the room, 4 into 3 into 3 is 36, divided by the total absorption which we just calculated. I will put up the numbers and you would anyways find the answer. Now problem with this question is it's going to take up 3 to 4 minutes. So as soon as you see this question in the exam, make sure you have a lot of time on the clock, sufficient time, and if not, go to some other question which takes less time. This can be solved. This is very easy. It just kills your time. So if you are struggling to keep up with the clock and you still want to make it into the top 100, plan your time accordingly. And finally, I'll end with your invitation to you. You can come and associate with us. Tell us about your queries, your problems. We'll be happy to help you with any issues that you have regarding your academics, or even for portfolios, resumes, admissions, etc, etc, etc. I'll be sharing our contacts in the description below, and some important videos would obviously be linked above. So see you in the next video. Thank you.